Radar reveals smarter, bird-safe offshore wind strategy. A landmark study from the Cornell Lab of Ornithology offers offshore wind developers a detailed look at how bird migration patterns can inform more sustainable turbine operations. By analyzing 10 years of weather radar data from 16 coastal sites across North America, researchers created the first large-scale migration baseline specific to offshore environments. The core finding? Birds tend to cross open water in short, intense pulses rather than spread out seasonal movement, particularly waiting for optimal weather to make the leap. These high migration nights usually align with low wind speeds, meaning turbines are already producing less power. This natural overlap presents a window for strategic turbine pauses during peak activity, reducing collision risks without materially affecting overall energy production. Birds migrating over water also fly lower, 13 to 20% lower on average than over land, placing them squarely in turbine rotor zones. This increased risk has amplified calls for data-backed mitigation strategies, especially given that offshore wind farms make carcass recovery and mortality assessments almost impossible. Radar now plays a critical role in filling that gap, offering operators a way to forecast and respond to risk in real time. From Europe to North America, a playbook for smarter wind operations. As offshore wind development accelerates along the U.S. East and Gulf coasts, industry and regulators are under pressure to balance energy generation with biodiversity protection. With up to one-third of American bird species facing steep declines, proactive measures are no longer optional. The study, published in the Journal of Applied Ecology, outlines how developers can use location-specific data to plan turbine operations around bird migration windows. For example, spring migration peaks in the western Gulf of Mexico, while fall activity is heavier in the Atlantic, suggesting that timing and impact vary by geography and require customized responses. These findings align with operational models already in use in parts of Europe, where radar-guided turbine shutdowns have been deployed during migration peaks. Co-author Adrian Doctor of the Birdcast project says similar systems could offer both regulatory clarity and public trust as U.S. offshore wind scales up. The research also involved scientists from the U.S. Bureau of Ocean Energy Management and the University of Amsterdam, offering cross-institutional validation of the data. For developers, the study provides both a framework for environmental compliance and a pathway to long-term operational stability. By embedding bird migration insights into siting and scheduling, the sector can reduce its ecological footprint while staying on track with production goals.